Alright, so I need you to finish your notes and you'll ask for some more explanations with dealing with finding the other extreme when given the geometric mean. Most of you are real good about if I give you the two numbers, following the two number rule, which basically says a number over x equals x times over, that number. So just to recap, a and b, when I cross multiply them, those are our extremes. And then the x times x, that is the geometric mean. I'm just going to abbreviate that. Sorry. So I can set up the proportion as such to find the other extreme, or I can use the simplified representation, which basically, because when I cross multiply, I get x squared equals a times b. And to get to that x, I'm going to take the square root of a times b. All right, so on this first one, we did the 96. Don't get scared by big numbers, but I'm going to set it up both ways just to recap. I could say since one of the extremes is 4 square root of 6, I can do 4 square root of 6 over 96 equals 96 over some number. And then cross multiply, which is when we had to square that, and 4 square root of 6 times x. And then you got, so you could set up here, or I can use my formula, my other formula that says the number, the geometric mean, is the square root of a times b. Since one of the extremes is this 4 square root of 6, so 96 equals, I'm going to end up still squaring. You're going to end up saying this. The square root of 4 times the square root of 6 times b. b is the number I'm trying to find. To get to that, I'm first going to have to square it. So notice I'm still going to square the 96, and then we're solving for b. So on number 4, and it was a large number. Don't get intimidated by that. They won't be that large on a test. But on number 4, you can set up two ways. One of the extremes is 6 over 2 square root of 6 equals 2 square root of 6 over the other extreme, which I don't know, and then I can cross multiply to solve this. Now you have to remember your radical rules, and so when we cross multiply, I'm just going to show the cross products, but basically we're saying 2 square root of 6 times 2 square root of 6 equals 6x. Well, outmates get multiplied together, so the 2 times 2, and then we have to remember what happens when you do square root of 6. Any radical times itself ends up, yes, that's the square root of 36, which we know is 6. So we get rid of the radical, times 4 equals 6x. And then you should get 24 equals 6x. And then you can solve for x, which is divided by 6. You know this already. So you could set up the proportion, or because I know the answer 2 square root of 6 is the geometric mean, 2 square root of 6 equals 6 times some number, and then I take the square root of that. Well, to get the x, I'm going to square both sides. So when I'm squaring 2 square root of 6, I'm squaring the outside number, which is the 2, and I'm squaring the radical 6, which gets rid of the radical, which I'm getting back to 4 times 6. And then this gives me 6x, and I'm back to where I was on the other one. So I'm not really going to stress the method. You pick a method. I know y'all asked for some additional problems. So here's another example. Let's say that 12, add this to your notes, is the geometric mean, and I abbreviate that, of 8 and what number? Okay, so I'm telling you 12 is the geometric mean, so there's two ways, two approaches we can solve this. 8, I'm going to rewrite this. 8 is one of the extremes, so 8 over 12 equals 12 over x, and then cross multiply, or I could say 12 is 8 times some number that I take the square root of. I'm going to have to cross multiply here on the left side, so this would give me 144 equals 8x, and I would have to square here to get rid of the radical. And notice I'm still going to get to 144 equals 8x. And then you just solve for x by dividing. Okay? Comes out nice and neat. If you want another example, we could say, let's do one with the radical. Let's say, say 3 is the extreme. is one of the extremes, sorry, of the geometric, sorry, I spelled that wrong, geometric mean of square root of 12. What is the other extreme? So if you want to write this additional example, put this into your notes and see if you can work it out. I'm going to just pause it and get to an answer so you can pause, and try to get to it too. It's right. Okay, I'm hoping we get to something similar to this, either method. You have the square to get rid of the radical. You're going to see real nice and sweet what it is, because when I multiply square root of 2 times square root of 12 times itself, that gives me 12. This is 3x. We should just get x equals 4. Okay. Alright, so the other thing you need to do is, number 5. Don't get intimidated by this because it's a big number, but it comes out. We're going to talk about exact answers and approximations. So first thing, most of y'all saw you had to do the Pythagorean theorem, and you did that. Everyone got to 26. Just a recap, you did 24 squared plus 10 squared equals the x squared, and then you actually got to 26. Now, in order to get the y, because your y is your altitude, and I'm abbreviating that, in order to get my altitude, I need the segments. This segment here, that's going to be g and h. I need the parts of the hypotenuse, because that will allow me to do the altitude rule, which is like the heartbeat. I can't get to that. But what I could do is I could do boomerang to get to G or get to H. I'm going to do G. So basically, boomerang says I do my hypotenuse to the leg, which will be the leg to the adjacent segment. All right, so I'm just going to come over here. Hypotenuse was 26 to 10, 10 to G. So that gave me, when I cross multiply, 26G equals 100, and then you're going to divide by 26, which is not, you're going to have to approximate, so a rational number. So G was or the exact answer is 50 over 13, okay? So now that I have that, I could subtract that from 26 and get H, and it would be a fraction answer to do the altitude rule, or I could do Pythagorean theorem again, now that I know what G is for the small right triangle. So that would be basically y squared plus 50 over 13 squared equals 100 squared, which is our hypotenuse. Alright, so I'm just going to simplify this for you. Y squared plus 2500, 50 squared is 2500, over 13 squared is 169, equals, and I put 100 squared, but that should have been 10 squared, sorry about that, which is 100. So to get the y squared by itself, I'm going to do 100 minus 2500 over 169. And then I have to take the square root. And this does work, okay? You would subtract first. If you subtract it, you actually get, 14,400 over 169. And then you take the square root of that. So square root of the top, square root of the bottom, gives you 120 over, and I wrote 160, but this is 169 over 13. So that is what the y is. Okay, so using Pythagorean theorem. You could use the altitude rule. Alright, so yes, be comfortable with getting crazy numbers. A lot of times y'all on the test, you second guess yourself because you're like, I got a decimal and it wasn't right. No, it can be a decimal. Alright, and then we'll talk about number 6. Hopefully you can see this is straightforward. Number 6 is using x as the altitude, so we're using heartbeat. So 7 over x equals x over 28. That gives me x squared equals 196, and then you take the square root. X equals 14. So that works out nice and neat. And then to get the y, you have to do boomerang. You have to do the whole hypotenuse to the y, back down the y to the segment. So 35 over y equals y over 28. And then you cross multiply. This one is not a perfect square, so try that one. Okay, check your work. All right, the last 2 problems, I need you to finish your homework. will be on our theory test like. So you had this first one, number 7. If you notice what parts you have labeled, you have the altitude and 2 segments. Anytime I see I have the altitude variable, I'm going to try to do my altitude rule. So, see if you can get your proportion. And then let's check quadratic for this one. So hopefully you can set it up as x is to x plus 5. The segment to the altitude is the altitude over the segment. You're going to cross multiply to solve. And you probably don't let it confuse you. Have these two perfect square brackets because they're both exactly the same term. If you forgot the FOIL method, you can just go straight from distributing one term at a time. So you're going to do x times x, which is x squared, and x times 5, 5x. Then go to the next term, plus 5x, and then 5 times 5 plus 25. And then we're just going to simplify that. It is a quadratic, and we're going to get the quadratic equal to 0 so we can solve when you factor it. So basically we have 20x equals x squared plus 10x plus 25, and then we want to subtract this 20x so it's equal to 0. And then I'm just going to come over here. X squared minus our 10x plus 25. And we're going to have that equal to 0. Let's get our factors. Factors of 25 with the sum of 10. Like I said, we had a perfect square binomial. So x minus 5 and x minus 5. So x equals plus or, actually it's positive, sorry, plus 5. So you get familiar with seeing basically multiplying 2 binomials together when you cross multiply and having to factor. We've done this before, the factoring. It's been a while since we had to use FOIL, but I know you can do it. And then the last one, I'm hoping you would see to start using your altitude. You can do your heartbeat if you want to call it that way, trace it. But we're going to have x plus 7, 12, which equals 12 over x. We're going to have a quadratic here too, but it's going to be nice and neat. So 12 and 12 gives us 44. We're going to do x times the x plus 7. Distribute your x. Some of you can skip this step because I think you know it already. We got x squared plus 7x. And again, we're going to make our quadratic equal to 0. So subtract the 144. I know you know to do that. Basically 0 is going to equal to x squared plus 7x minus 144. Alright, so now you're trying to come up with factors of 144 and negative 144 at that with the sum of 7. I'm going to let you try that. Pause the video. At this point, I'm going to go ahead and put the answer up here. And then you have to plug it in so you can get your y. So hopefully we got x equals 9 and x equals a negative 16. For this purpose, we want to use a positive value to get our side lengths. So when I plug that in, we know one segment is 9, the other one is 16. So now I can see my hypotenuse is 25, and then I can use boomerang or the leg rule to set up the proportion to solve for y. So try to do that. Hopefully you get y equals 15. If you did not get to that, then we need to be asking questions tomorrow in class. Now, besides completing your notes, we had a packet that we started on in class. But you need to go ahead and start working on that. It will be turned in for grade. Let me find it. It's not just class. It is, yes, right here. So we did simplifying radicals. You can do your geometric mean. Just to review, h is your altitude. I think we even started on this for some classes. And then we saw that h is the geometric mean between, which our segments are x and y. And then a is a leg. It is the geometric mean between z and x. b is also a leg. It would be the geometric mean. Use your hypotenuse, which would be z, and y. Alright, so I will have a partial key for this to help you with this. I'll just do that again. Already on Emoto, giving some hints, having some of the problems worked out, but you should be using your altitude rule, your leg rule, heartbeat, or boomerang. Then some more practicing of simplifying. There will be some hints with that. Find the geometric mean, multiply, take the square root. And then you definitely get some hints because when the figure's not drawn, you need to draw it. And then we're going to see if we can apply the geometric mean and with some more problems. All right, so if you have questions, come to class, ready to get those answered. And test is on Thursday. All right. Thank you. Bye.